This is a problem from one of the past papers, just a trigonometry and bearing problem. So Bargate is 6 kilometres east. So here's Cape Point. So Bargate is 6 kilometres east and 4 kilometres north of Cape Point. So from Cape Point, you would go 4 kilometres north and 6 kilometres east, okay? Now, Steve wants to sail directly from Cape Point to Bargate. On what bearing should he sail? Now, look, when you see a question like this, there's a few things they're going to ask. They might ask what bearing he's got to sail from Cape Point to Bargate. Or they could ask for the distance between Cape Point and Bargate. How could you work out the distance between Cape Point and Bargate? The distance. Right, good. So the distance would be Pythagoras' theorem, but they're not asking that. But sometimes they can. So he wants to sail from Cape Point to Bargate. On what bearing should he sail? Remember, bearings are measured from north, and then you go clockwise. So you need to work out the angle that you want, and you would work out this angle. That would actually be the bearing. From Cape Point, start from Cape Point and go clockwise till you get to Bargate. So you just want to find this angle for part A. That's not the hard bit, okay? So most people are able to do that. But you've got to identify the bearing from Cape Point to Bargate. Is that? Here you would just use some trigonometry. Tan theta is opposite over adjacent, which is 6 on 4. And, you know, most of you were able to do that. So what did we get for that one, girls? So ladies, we're getting 56 degrees, and that is to the nearest degree. But when you write the bearing, it's always a 3-figure bearing. So you have to write anything less than 100 with a 0 in front of it. So the bearing is 056 degrees from Cape Point to Bargate. Now, the angle, tan of an angle is 6 over 4. The angle is tan to the minus 1. Inverse tan of 6 on 4, which is 56 degrees. So the bearing's 56 degrees. Now, the next part of the question, ladies, you can't do the second part of the question unless the first part is already done. Notice this is 56 degrees. It says Anna sails from Cape Point for the next part on a bearing of 48 degrees. She stops when she is due north of Bargate. How far north of Bargate is Anna? So she sails from Cape Point on a bearing of 48 degrees. So, girls, if this angle here is 56 degrees, she's not making that much of an angle. She's going maybe like this. Do you get that? If that's 56, so I'm going to draw in a line for what Anna's doing. And she's sailing more like this, but she keeps going until she's north. So if that one up to the dotted line is 56, I mean, this could even be more north. It doesn't matter. Anna will end up here. Okay? Now, and this angle here for Anna is 48 degrees. Basically, what we've got here is that we've got 48 degrees here, and Anna's over here. I've got to draw up a new triangle, which I'm going to do here. Now, you might think you don't know any side length measurements, but you actually do. So we've got a right angle triangle here. Tell me what this distance across here is, girls. Yeah, 6, the same as that. So if you don't see that, you wouldn't be able to do the question. So this is 6 kilometres because Anna has ended up directly north of Bargate. So the length from here to here is the same as from there to there, which is 6. Well, you need to, because you need to draw a right angle triangle. Or you could have come back here, down here, and drawn a right angle triangle. But it's best to go up there. So what we've got, I'm just going to come down here for a sec. So what we've got is the following. This is what we've got. So now our new triangle is that this is 6 kilometres and this is 48 degrees. And I really don't know anything else. Now, that's all I know in this triangle. But with this information, I could either find this side or this side, okay? Now, the question says, how far north of Bargate is she? Now, I need this distance, right? But remember, this distance is really this distance over here. So I know that this bit is 4 kilometers, but if I find this whole side here, I can then subtract 4 kilometers to find this bit. That's really what I want. I know I want this bit here that I'm marking, but that is the same length as this bit because this is a rectangle up here. So if I find the length of this whole side, because from there to there is 4 kilometers, I'll then be able to subtract 4 kilometers from there. Okay? All right, so coming down here, I want to find, I'm just going to put this as D or N. It doesn't matter. So what are we going to use? Sine, cos, or tan? Opposite and adjacent. So tan of 48 degrees is opposite over adjacent, which is 6 over D. Remember when what you're finding is on the denominator, you do your little swap. D is 6 over tan of 48. Anyone got an answer for me, please? So D is, what have we got? 5.40, etc. kilometers. So therefore, the answer, how far north? Remember, we've got to subtract. Well, I'm just going to go back up to the diagram for a minute. So I've just worked out that this whole bit is 5.4024, etc. That's what that bit is on my diagram. So I just subtract, okay? So how far north? North of B is 5.4024 minus 4, which is 1.4 kilometers. I'm just going to go to 1 dp, to 1 decimal place. That looks like told. Why do you have minus 4 there? Oh. Because, yep. Okay, so it's 1.4 kilometers north of Bargate. Ladies, shh. Okay, there are 2 ways you could do this. The first method is to use index laws. So 2 times 3 is 6. A to the negative 3 times a to the power of 5. A to the negative 3 times a to the power of 5. The bases are the same, so we add the indices. Negative 3 plus 5 is 2. Then we've got b squared times b to the power of negative 4. The bases are the same, so I add 2 and negative 4 and I get negative 2 over 8a to the power of 6. Now, look, girls, I'm going to show you another way to do this, but this is one way. Now, what I would do if I were you, I would move this b to the negative 2 onto the denominator. We okay with that? I'm going to show you another method to do the first step as well. If it's b to the negative 2 on the numerator, it's b squared on the denominator. Now, girls, 6 over 8 is 3/4 if you simplify that fraction. A squared over a to the power of 4. Where have you got the extra a's? On the? Girls, that's a times a over a times a times. There's 4 extra a's on the denominator. And b squared is also on the denominator. That's one way to do it. Another method to do the same question would be to move any negatives. I would move any negatives. So a to the power of negative 3, I would move down. I'd keep the b squared at the top. Now, the only reason you can do this is because of the times. Everything's multiplied or divided, it's fine. As long as there's no addition or subtraction signs there. So the next one, 3a5, I would put that b to the power of 4 on the bottom. Okay, now I know it's looking a bit weird. I'm putting the a to the power of 3 on the bottom. I'll keep the 8a to the 6 on the denominator, and I'll move the b to the 4 on the denominator. It is okay to do this because of this multiplication symbol here. I'm just moving the negative 1 down and the negative 1 down. And when you move it down next to something, it's now next to each other. They're multiplied by each other. That is the other way to do this. So I would have 6a to the power of 5b squared over 8 a to the power of 9 b to the power of 4. And now I start cancelling out. 6 over 8. I actually think this particular one is easier to do it like this. Girls, you can use the index laws as long as the bases are the same. What you're really looking at here is a to the negative 3 times a to the 5. The bases are the same. You add the 2 numbers. You all know how to add and subtract negatives. All right. Looking here, 6/8 is 3/4. I've got an extra 4 A's on the bottom and an extra 2 B's on the bottom, B squared. Just remember that's B times B. This is B times B times B times B. And 2 B's from the numerator and the denominator cancel out. So 2 ways to do that. Problem question 4. A car travelled from X to Y on a bearing of 240 degrees. Now, when you see that we're starting from X to Y. So you've got to work out where that 240 degrees is. So from X, we put a naught sign, and then we go clockwise until we find the direction that Y is on, and that is 240 degrees there. And it says it left X at 9:10 a.m. and travelled at an average speed of 90 kilometres per hour and arrived at 11:20 a.m. Okay. It then travelled 400, so it went to Y, and then it travelled 400 kilometres to Z on a bearing of 150. So we need to put where this 150 is. So it went from Y to Z on a bearing of 150. So we start from Y. We've got our north sign, and we go clockwise from north for 150 degrees until we find Z, which is down here. So then we have to mark that in as well. Okay? All right, ladies. The first question here is to explain why the distance from X to Y is 195 kilometres. How do you think we're going to do that, girls? How are we going to do that? Well, you know what time it left. You know what time it arrived. Yes, you're going to use your distance, speed, time formula. Okay? So what is your distance, speed, time formula? So distance, so we've got our little triangle here. Distance, speed, time. So what is distance, girls? How do we do it? Speed times time. Speed times time. But girls, we've got to be very careful here because look at our units. Our speed is 90 kilometres per hour. But the time, what is the time? How long is that? Okay, so our speed is fine. It's 90 kilometres per hour. But our time is 2 hours and 10 minutes. Girls, how am I going to write that as hours? How am I going to write 2 hours, 10 minutes? I need to write that in terms of hours. Well, that would give me in minutes. What fraction of an hour is 10 minutes? It's 1/6 of an hour. So 10 minutes is 10 out of 60, okay? So it's 2 hours plus 10/60th of an hour. That is 2 and 1/6. Are we okay or not? Do you know why I'm doing this? Why am I making it into hours and not minutes? Because my units of speed are kilometres per hour. So my units of time needs to be in hours. So my 2 hours is fine, but my 10 minutes needs to be in hours. Okay? So it's 2 and 1/6 hour. Girls, how... Thank you.
I'll be signing up for the lesson soon.
Okay. All right. So, girls, what are you going to do with this now? What are you going to do with that? 2 and 1/6 hour. I mean, you can just times by 2 and 1/6, but it would be nicer to change this to what? An improper fraction. So that's 13/6 of an hour. Now, I already know that 6 into 90 is 15. I don't know what 15 times 13 is. What's the answer? About 100 and something. Yeah, 195. Okay, so that's my distance. So explain why the distance from X to Y is 195 kilometres, which we've just done. Okay, now. It then travelled 400 kilometres on a bearing of 150 degrees. So this is what we've got. Now the next question says to explain, are we all good? It says to explain why angle XYZ is 90 degrees. XYZ. Why is it 90 degrees? Now girls, when you're doing this, you need to work with alternate angles and things like that. So girls, what's this bit here? If that's 240 all the way there, what's this little bit here? Up to there's 180. 240 minus 180. This little bit here is 60. Or look, some people have worked.
That's 60.
The other one's 30. That's fine. So girls, what I'm going to do now, I'm going to do alternate angles. Alternate. This bit, can you see what I'm doing? That's 60 here. Now, if that is 150 and that bit there is 60, can't I? I can subtract. It's 150 minus 60 is 90. Now, girls, when you do this, you might want to say that you've got alternate angles here, but I'm very happy for you just to put arrows and just say that you've got alternate angles and use your diagram are equal. You can use your diagram here to show that they're alternate. Look, if it's 2 marks, yes, I would, that you've got alternate angles there. I mean, look, some people would have done it another way as well. Some people could have said, ladies, that if that's 60 there, they could have put that that bit up there is 30, and some people did do it like that, that this bit here is 30. So if that's 30, you can do your alternate this way, and that bit's 30. And if that bit's 30, that bit's 60. I don't know. How are you finding that one? Which one do you prefer? So this could be 30. So, girls, the other way you could have done it, if that's 240, that's 30. Because it's 270 minus 240. You could have done alternate this way. 30. Then you would do... Actually, that doesn't help. Don't do it that way. Oh, you could, but I probably wouldn't. I would stick with the first method. If you want to put that that's 30, you're going to have to do a lot more work. You're going to have to go, yeah, it's just going to be a lot more work. I wouldn't do it. All right? Well, you'd have to say that's 30, then you'd have to say the rest of it is 60 because the whole lot's 150, and I think that's more confusing. Okay? Now, for the next bit, how far is Z from X? Girls, that one's standard. How do you do that one? How far is Z from X? Anyone? You don't. You know, you've just shown that that is a right angle. You've just shown that that's a right angle, so you just use Pythag. So you go XZ is 195 squared plus 400 squared, and whatever you get. Girls. So girls, in the other part, we just found that this was a right angle. Okay, so you've got a right angle triangle. You can just use Pythagoras' theorem now. We've got 195 and 400. They're asking for XZ. That's all they're asking for. That's why in the previous part, they said show why this is 90 degrees. So then you use Pythagoras' theorem. Did anyone get an answer for that? And then what you get for the square root. Now, the last bit. Last question. What is the bearing of X from Z? Girls, what is the bearing of X from Z? So, start from Z, put a north sign, and go clockwise until you find X. Now, I've got to work out what that angle is that I've marked. I'll do it in red. Now, girls, I'm not going to be able to do this in one step. What I need to do, girls, if this is 150 up to there, so this is my north line. This is worth 3 marks. The first thing you want to do, I'd be working out this angle theta just there in the triangle. Work out the angle theta in the triangle. Do you know why I'm working this out? Because I've got to work out the distance all the way around there plus that extra bit in the triangle. You're going to get 2 marks for just working out that angle in the triangle and 1 mark for the rest of the tricky bit, which is the actual bearing. So, no, we can't. No. All right, so this is what we've got. Yeah, I've got theta. I've got this. This is what I've got in that triangle. X, Z, Y. I've got 195 and 400. If I want this angle theta, I would use tan theta is 195 over 400. Theta is the inverse tan of 195 over 400. And work out that angle first. So, girls, if it's 25.98, you round it to the nearest degree, which is 26 degrees. Okay? Now, ready? We then go back to the diagram. So, girls, I know that this little bit here in my triangle is 26. So I've got to work out what this whole thing is. Either if I know what, I don't think I know what this bit is. I don't, because I can't do alternate here because I actually don't know what this whole angle is. So I've got to come back down here and work it out. Now, if this is 150 up to there, what's this bit here? If that's 150 up to there, that's 30. Now start using alternate angles. So ladies, what I've got, if that's 30, the alternate way is a little bit tricky, but if that's 30, so is all of this. It's also 30. Can you see it? Alternate. Can you see that or not? Yeah. So girls, if this is 26, what's this little bit here? 4. That's one way to do it. I know there's a lot on this diagram. I'm sorry. So we've got alternate 30. I really need another color. So I've got, this is 30. I can do my alternate, and that whole thing there is 30. But I know this little bit here is 26, so that bit must be 4. So therefore the bearing is a full circle minus 4 degrees.
Can you scroll down?
1 minute. So therefore the bearing is a full circle minus 4, which is 356. I'm going to show you another way to do that bearing. There is another way to do that bearing. All right, I know I worked out the 30, but see how it's getting very, very messy? Your other way, girls, when you can do alternate, you should be able to do co-interior as well. So you know how I've got 30 here? Why don't I do co-interior? Tell me what this bit down here is, just that bit. Anyone? 150. So I could do co-interior. I'm going like this, 30 and 150. Can you see what I'm doing? Now I know that around here is 180. So what I've got, the other way to do it is 180 plus 150 plus the 26. Okay, that is the other way to do it. To do the 180, the 150 plus the angle that I just worked out in the triangle, which was 26. That's the other way. Or I could have done 180 plus 150 plus 26. That's 356 degrees. Okay? Come to draw angles of depression and things like that. Remember, do you remember me saying, don't we walk around with our eyes straight ahead? So, angle of depression is measured from the horizontal looking down. Your normal eyesight is like that, and then you look down a bit. So, a news helicopter hovers at a height of 500 meters. The angles of depression of a fire moving in the direction of the helicopter are first 10 degrees. So here's the helicopter. 10 degrees. Looking down. Remember, you look ahead normally, and when you do an angle of depression, your eyesight is, it's that. Yes. It's being recorded. So girls, your normal, look at the pen, eyesight's normally like that. You put your head down 10 degrees. And then it moves, then at the next measurement, the depression is 15 degrees. So that's bigger. So the fire must be getting closer. Okay, we've got a right angle triangle. Fire 1, fire point 2. Draw a diagram based on that information, which we've done. And then you have to find the distance moved. I have to find this distance. Right, with angles of depression, you always do alternate angles. So that one's 15. You can only work with right angle triangles. So what you do you've got your first right angle triangle. I might just call this X. And then I'm going to call the other one Y. So that's 15, 500, X. And in the other one, 10, Y, 500. Find each one and subtract the answers. Yes, okay? And you would use tan. And, you know, swap them, etc. Okay? And solve for Y and X and then subtract.